Oh, hi, Mr. Fritz here. We're going to talk about rational functions, and we're going to do some operations with these rational functions, like a surgeon. And we are going to dive right into this. Let's talk about what rational functions are. What is a rational function? Well, let's first think about other rational things. What you've seen in the past, you've seen rational numbers. Example of rational numbers would be 1 over 2, 14 over 3, 4 over 1. By definition, a rational number is the ratio between two numbers, two integers. So even I can include like negative 1 over 2 in this list, or 15 over 3. These are all rational numbers. And rational numbers can be simplified into other numbers like just 5, but that is a ratio between two numbers. Rational exponents are exponents that have rational numbers as exponents. So here you'll notice that we have a ratio appearing in the exponent. This would be a rational exponent. Other rational things might include saving money for college, or I don't know, studying before math tests. But these are all different types of rational things. For the math world, these are two examples of rational things that you've seen so far. A rational function, here's a definition that I encourage you to write down for a rational function. A rational function is an algebraic fraction such that both the numerator and the denominator are polynomials. So for an example, x squared plus 2x plus 1 over x minus 5 is a rational function. So too is something like this: x plus 3 times x minus 4 all over x plus 1 times x squared plus 7. These are rational functions. It is a ratio between two polynomials. In general, we could just have f of x over g of x represent just what a rational function is. It's two functions, one in the numerator, one in the denominator, and we're taking the ratio between them, we're dividing them. That's a rational function. So how do we simplify rationals? Well, let's think, before we get into simplifying rational functions, let's think about just simplifying rational numbers, aka fractions. And let's kind of think about like how we simplify this number. You all know how to simplify fractions, but let's think about what's actually going on under the hood with this. First, to simplify the fraction 24 over 15, you might break it up into 8 times 3 and 5 times 3. We kind of factor the numerator and the denominator. We don't usually write this out, but this is what we are kind of doing in essence when we are reducing common factors out of your numerator and denominator. Here I'm actually canceling out a 3. I'm reducing a 3 in the numerator and 3 in the denominator, which reduces to 1 and 1. And 8 times 1 is 8. 5 times 1 is 5. So this would be my simplified fraction. All the common factors that exist in my numerator and denominator get reduced out of there. So we're going to apply the same strategy for simplifying rational functions. So here I have a numerator that's some polynomial and a denominator that's some polynomial. And the first step that I would recommend is to factor the numerator and the denominator. When we factor the numerator and the denominator, we are separating out possible things that we can reduce. We can only reduce when we have common factors. A lot of people might say, or might have an inkling to say, well, I can reduce by an x squared and an x squared. That's not okay, because x squared is not a factor of this numerator, nor is it a factor of this denominator. That is not a way to simplify. This is one entire polynomial, and only can we reduce once we have factored the numerator and the denominator. At this point, we want to look for any sort of domain restrictions in this polynomial. And how you find domain restrictions, you want to think, if the denominator ever equals 0, that's going to give you a domain restriction. So really what you're doing is you're going to set this denominator equal to 0, and you're going to solve for x. So if x plus 3 times x minus 2 equals 0, then x could equal negative 3 or x could equal 2. That would get my denominator equal to 0, which is not an okay thing. So these are restricted x values in my domain for this polynomial rational function. And then finally, we can reduce any common factors. I have a factor of x plus 3 in the numerator and a factor of x plus 3 in the denominator. And so those two reduce. They simplify because they equal 1. And what's left is x plus 4 over x minus 2. and I need to state my restrictions for my final solution. So I've reduced any common factors and stated domain restrictions. That's it. Same thing as we did with numbers, but now we just have x's in the mix. So why don't you try this example here, follow the same steps we did in the last one, pause the video, and when you're ready, check out the answer. All right, so here is my solution to this. You can check it out for yourself to see how it went. And in the next video, we're going to move on to multiplying these rational functions.